Hey everyone! It's kind of funny, but in math, just like in real life, variables have relationships, and they follow certain rules. The cool part? Once you learn those rules, you can totally predict what's going to happen next.
So, let's think about something we all get, driving. How are speed, time, and distance all connected, right? If you drive faster, what happens to your travel time? It goes down. See? They have a predictable relationship. Well, that's exactly what we're diving into today, the rules that make these connections work. Okay, let's start with the easiest one, the one you probably already know without even realizing it. It's called direct variation. Basically, it's when two things are perfectly in sync. The more you work, the more you get paid. One goes up, the other goes up. Simple, right? Now, the secret sauce is this little formula, y equals k times x. Now, y and x, those are the things that change, like your paycheck and the hours you worked. But k is the magic number. It's the constant, the thing that doesn't change. In our job example, k is just your hourly wage. It's the rule that connects everything.
Okay, let's actually do one. So, the problem tells us that y is -3 when x is 24. Our first mission always is to find that magic number k. We just plug in the numbers we know, solve for k, and we get -1/8. Great! Now we have the rule for this specific relationship. So, the question is, what's y when x is -16? Well, we just use our new rule, pop in -16 for x, and boom, y equals 2.
Okay, now it's your turn. You can grab a piece of paper or just do it in your head. It's the same exact two steps. First, find k using the numbers they gave you. Y is -9 when x is 6. Once you have your k, use it to figure out the new y when x is -7. Go ahead, I'll wait. And the answer is 10.5. Did you get it? So if you plugged in -9 and 6, you should have figured out that k is -1.5. Then you just take that and multiply it by the new x, which was -7. And remember, a negative times a negative gives you a positive, so 10.5, awesome job. All right, so direct variation is a simple partnership, right? Just two variables. But what happens when you add a third wheel to the mix? Well, that's where our next type comes in, joint variation. Think of it as a team effort.
Check out the formula. See what we did there? Y equals k times x times z. We literally just added another variable to multiply. So instead of just one thing affecting y, now we have two things working together. But here's the best part. The way you solve these problems, it's exactly, and I mean exactly, the same. Let's prove it with this example. Okay, we're told y varies jointly with x and z, and they give us a whole set of numbers to start with. So what do? Same thing as before. We plug everything in to find our constant k, which in this case is 1.25. Then we use that k with the new numbers to find our new y. See, it's the same process, just with one extra number to multiply. No big deal.
Okay, you know the drill. Time for you to try one. Use that first set of info, the y, the x, and the z, to find your constant k. Then use that k with the new x and z to solve for the final y. You got this.
And the answer is 60. For this one, your magic number k should have been 3. So when you multiply 3 times -4 times -5, you get that positive 60. See? You're totally getting the hang of this. So up to this point, all our variables have been buddies, moving in the same direction. But what about relationships that are, well, the opposite? That's where inverse variation comes in. Let's go back to our car example. The faster you drive, the less time it takes, right? One goes up, the other goes down. They're like a seesaw. And the whole secret is right here in the formula. Take a look. Instead of y equals k times x, now it's y equals k divided by x. That little change, from multiplying to dividing, that's what creates the whole opposite effect. When x gets bigger, y has to get smaller to keep things balanced. It completely flips the script. Let's look at how this works in a problem. So m varies inversely as n. We get our first set of numbers. Now pay attention, because this is the one different step. To find k this time, you actually have to multiply m and n together. That's the key. In this case, that gets us k equals -24. But after that, after you find k, the rest of the process is exactly what you'd expect. All right, your turn to try an inverse problem. Just remember that little twist in the first step. To find k, you're going to multiply your first pair of numbers. Got it? Then, once you have k, it's just a simple division to find the answer. So how'd it go?
The answer is negative 22.5. Your constant k should have been 135 because 15 times 9 is 135. Then you just take that 135 and divide it by the new number, negative 6. Simple as that.
Okay, let's just pause here for a second, because this is the whole thing in a nutshell. Direct variation on the left, y equals k times x. They go up together, they go down together. Inverse variation on the right, y equals k divided by x. They're opposites. It really all just comes down to one thing. Are we multiplying or are we dividing? That's it. All right, we've learned the individual dance moves. Now it's time for the big finale where we put it all together. This is called combined variation, and it's exactly what it sounds like. We're going to have a variable that has a direct relationship with one thing and an inverse relationship with another thing, all in the same problem. Now, this might look intimidating, but I promise it's super simple if we just follow a recipe. Step 1, anything that varies directly, it goes on top, in the numerator. Step 2, anything that varies inversely, you guessed it, it goes on the bottom, in the denominator. Once you've built your equation that way, the rest of the problem is exactly the same stuff we've already been doing. Let's do one together. The problem says A varies directly as B and inversely as C. So following our rules, B is direct, so it goes up top with K. C is inverse, so it goes on the bottom. And there's our equation. From here on out, it's the same old story. Plug in the first set of numbers to find K, then use that K to find the final answer.
Okay, this is it, the final challenge. This one uses everything we've talked about. So read the sentence really carefully. Figure out what goes on top, what goes on the bottom, build that equation, find your constant, and solve for z. You've totally got this.
And the answer is 49 over 6, which is about 8.17. Your equation should have looked like x equals k times y, all divided by z. Using the first set of info, your k would be 3.5. Then you just plug in the rest and solve. Amazing job! So let's just recap the whole thing. It really boils down to this. Direct is all about multiplying and things move together. Inverse is about dividing and things move in opposite directions. And joint and combined, they're just fancy ways of mixing those two simple rules. This little chart here is basically your cheat sheet for everything. And that's pretty much it. But the real question is, now that you know these rules, where are you going to see them out in the wild? I mean, think about it. Cooking, planning a road trip, even in business or science. These relationships are hiding in plain sight, everywhere. So what connections are you going to spot now? Thanks for hanging out and figuring this out with me.